absolute value functions. And again, we're only going to be dealing with polynomials, most of the time linear polynomials. So you're looking at some f of x is the absolute value of some polynomial. That's all it is. So we look at some simple examples. Say, for example, I look at a linear polynomial. So f of x is the absolute value of, 2 minus 5x. Okay, let's start to reason through this. What is the domain? Well, the first thing we discover, or we should recognize, is I can put any value of x to that. What comes out must always be positive. What goes in can be anything. So the domain of this, if you're looking at this, is that x is any real number. There's no way I can put in a number and have this to be undefined. I'm looking for, is it ever undefined? No, it's never undefined, so I'm okay. Now, the range is a little more subtle. We know since it's an absolute value, the only thing that can come out of this are positive quantities or 0. So for all of these, the range of these is going to be, if it can be, we're going to see for this one, y has to be strictly greater than or equal to 0. Now let's verify that. Let's plug this into our graphing device, whatever we choose to use. Now also practice this on your TI calculator, so you'll have that, because that's what you'll be able to use during the test. It's a good way of understanding these things as well. Make sure I'm on here. Yeah, should be. Okay, so I'm just going to be putting, now I'm going to use the, I think is it ABS? No, it's not. So let me go over here and use the calculator over here. Should have, there we go, here's my absolute value. And 2 minus 5x. I think there's a straight line. I think there's a straight line. Where is it? Trying to see. Yeah, it's here somewhere, but I can't see. Doesn't matter. Here's a picture right here. And you can kind of see the domain is any value I can put in. I'll always have an x. But the range goes from 0 to plus infinity. It's along the y-axis. Okay. So that's how you analyze these. Now, sometimes you may have something like this. That's one example. So you have to be careful with the range. The domain is always all real numbers. The range, you have to be careful with. Let's try that same, to a quadratic polynomial that we had of f of x, now looking like this. Absolute value of x squared plus 4. Just the other same function I had in the argument of the radical a moment ago. Again, absolute values, I can put anything in there. So the domain is x can be any real number, not a problem. What about the range? Well, can this thing ever be 0? No, it's impossible, because x would have to be a strange type of number. We know it's later on we'll define it as an imaginary number, so it can't be 0. The smallest value this can get, the smallest height this can get above the x-axis is when x is equal to 0. So that means I can get down to the absolute value of a positive 4 or larger. So the range is that the y value has to be greater than or equal to 4. Now, if we're not sure about this, plug it into our calculators and you'll see. So we have our calculators, and we can kind of take a look at that. Or my screen calculator over here. So put my x squared plus 4. And there it is. Since it's already positive, it doesn't do anything at all to that expression. It just gives me the parabola x squared plus 4. The only thing the absolute value does, it'll turn a negative into a positive. Everything else is the same. Now you can see where it can get interesting. You can get some strange looking results. Say I put in x squared minus 4. Now you see what happens. It took that same parabola, which would have extended down beneath and gone down to minus 4 over here, and all those negative values beneath the x-axis, it's flipped them up and made them positive. So it can do some strange things, the absolute value function. Because the absolute value just takes whatever is the argument and always makes it positive. If it's negative, it multiplies by -1 and changes the sign. If it's positive, it just leaves it alone. Okay, so absolute value is not so bad. You just have to be aware of what it is and what its definition is. Now in the textbook, I gave you the official definition of what an absolute value function is. Take a look at that. This is the analysis where we're finding both the domain and the range. So if it's linear, the domain is always going to be all real numbers, and the range, as long as this is linear and there's not a negative out front. Now you got to be careful, because you could put a negative out in front of the absolute value. Well, that changes everything. The domain is still the same, but it then flips around the range. Now that becomes y is less than or equal to 0. And just plugging that into your calculator or your graphing calculator, you'll see it will look something like this. So you can see where the y value is on the x-axis or beneath the x-axis, but not above it. You just have to be a little bit careful. So that's all it is. So we're going to be dealing with these algebraic functions. And a lot of the time we're looking at the graphs of these functions and what they look like. And use whatever technology you've chosen, either the TI calculator, there's many in that family that you can use, as well as Desmos, there's GeoGebra is another nice graphing online calculator technique. Desmos, and I think GeoGebra is also movable over onto our smartphone. So you can actually put a application of Desmos on your smartphone and use that as a graphing calculator. I mean, most smartphones do have your scientific calculator. Some of them you might be able to buy an app, but Desmos is a free app, so I would just do that for free. TI might have a purchasable app for them. I'm not sure on the smartphone. Okay, so we looked at the radical functions, mainly square roots and cube roots, and some of the issues there, and finding the domain and range, and absolute value functions, finding the domain and range. For both types, we have the graphical guide to help us understand them. So on these next two sections, that's what you're mainly asked to do. Given a function, find its domain and range. Where you have some problems on some of the radicals, if you have the square root of a quadratic, that might get a little more problematic. And you might have to do some extra work there. You can plug it into your calculators, but sometimes in the calculator you don't get everything, all the details that you want. Luckily for this course, you'll get most of everything you need, but not 100%. You need to really be able to do all of those analytical techniques to be successful.